All right, guys. So this week we're going to look at exponents. A lot of these things that we go over this week is going to be a review from 8th grade, but 8th grade has been a minute, right? So I think a good review is always necessary. All right, so the first thing we're going to talk about is the term monomials. So monomials is a expression that has one term, right? And what normally separates terms are addition signs and subtraction signs. So we're going to look at monomials and multiply monomials together, and then we're going to divide monomials. So the first thing I want you to remember is that these two expressions right here on the top of the page are indeed different. This is like saying 2x times 2x times 2x. This one is saying 2 times x times x times x. So wherever the exponent is, whatever it's directly connected to, that's the only thing that's being raised to that power. So 2 times 2 times 2 is 8, and x times x times x is x to the third. And this answer is simply what we started with, 2x to the third power, okay? So remember, when you have exponents raised to exponents, you multiply those two exponents together. So I don't see an exponent next to the 2 nor the x, but they both have an exponent of 1. So 1 raised to the third power, 1 times 3 is 3. And 1 times 3 is 3. That's why we get 2 to the third power times x to the third power, which is 8x cubed. Okay. Another reminder is the zero exponent property, which means any which is anything, any base raised to a 0 power is equal to 1. Anything raised to a 0 power is equal to 1. So a raised to the 0 power is 1, and 5 raised to the 0 power is also 1. So what would be 100 raised to the 0 power? The answer is 1, right? So that's a good reminder. You learned that in 8th grade. So when you're multiplying powers together, you take a number that have the same base, and the rule is you add those exponents together. So x squared, that's a base, times the base of x to the fourth. So the bases are the same. So basically we have a total of 6 x's here. X times x times x times x times x times x is basically x raised to the 6th power. And then we have the base y times the base y. So 3 plus 2 is 5. So that is the answer to these two monomials being multiplied. All right, so here we're going to find the same base. Now don't forget, I don't see an exponent, which automatically makes it a 1. So we have the base of a, and 1 plus 3 is 4. So a to the 4th. We have a 2 plus 4, so b to the 6th. And then c, 1 plus 1 is c squared. And that's the second one. So here we have a coefficient. So 3 is our coefficient. It's not attached to an exponent. 4 is a coefficient. It's not attached to an exponent, but it is attached to variables. So they are coefficients. So we are literally going to multiply 3 times 4. So 3 times 4 is 12. And then we have x to the first times x to the first, which is x squared. And then our y is by itself. So that's the third one. So the fourth problem, 4 times 2 is 8. A to the 5th, a to the 5th, b cubed. That's an a, even though it didn't look like it. And then finally, the last one is 10 times 3, 30, x to the 5th, y squared, z to the 3rd. Okay? And always feel free to work ahead of me and then just watch the video to check your answer. That'd be great. All right, what about this? So on Thursday, your assignment is going to be this sheet. And so some of the problems are addition, some are subtraction, some are multiplication. So I just want you to remember to use all those rules together. So you are going to on number or L, I guess this is an I, letter I. So all we're going to do on this one is add our coefficients because n squared and n squared just tells us these are like terms. Remember that? And so we bring over our base and our exponent. So I is 7n squared, which is number 13. So go to number 13 at the bottom and write an I there. Now the letter L, this is being multiplied. So we're going to multiply those coefficients and get 10. And then since our exponents that have the same base are being multiplied, we're going to add them together and we get 4. So 8 is letter L. All right, what about letter G? Can we add anything? Are these like terms? None of them are like terms, right? So this is the final answer. There's nothing we can do, which means 28 is G. Okay. So you guys keep on moving on. Okay. What about this side over here? So we have a little bit of everything. So on letter D to the right, we have two like terms. So we're going to combine -4 and -9 and we get -13. K to the third and then plus 4k squared. So that one is 18. 18 is D. No, wait, that's not right. Oh, yes, that's right. Sorry, I'm looking at the wrong puzzle. I'm like, wait a minute, did I get that one wrong? Yeah, 18 is D. All right, so then let's jump down to letter N. That one looks more complicated. So letter N, this is a multiplication problem. And this is a multiplication problem. And the last thing we'll do is subtract them. So we're going to multiply 8 times -3 times -1, right? There's a -1, that coefficient. So -3 times -1 is +3, and 8 times 3 is 24. And then we're going to add all of those exponents that have a base of k. So 1 plus 2 is 3, plus 7 is 10, minus, all right, we're multiplying 2 times 3 times 4. So 2 times 3 is 6 times 4 is 24. And then our k's, we're going to add those. 3 plus 3 is 6, plus 6 plus 3 is 9. So 24 minus 24 is 0. Oh, actually, what am I saying? Those are unlike terms. I was about to try to add those. You cannot because they're unlike terms. So that's our final answer. So N goes with 29. All right. N is 29. I almost got tricked. Sorry about that. All right, so why don't we do one more? Let's do letter Y. So letter Y, once again, we have multiplication, and then we'll subtract the last two terms. So 7 times 2. So remember, you can't add or subtract unlike terms, but you can multiply unlike terms. So 7 times 2 is 14. So we have 14, and then K, we have 2 plus 1 is 3. 3 plus 3 is 6. So 14k to the 6th minus 5 times 3 is 15. And then we have k to the 6th. Well, the k to the 6th make these like terms. So basically, we're just thinking, what is 14 minus 15? So the answer is -1. So -1 times k is -k to the 6th power. -k to the 6th power. So 4 goes with the letter Y. Okie doke. So hopefully that helped. That little reminder will help you guys finish these, and you can figure out what the punchline is, and you will send that to me for your grade for the day. All righty. All right, so then Friday's lesson starts with a warm-up. I wish all of them did, just to remind us of things we've done in the past. But anyway, hopefully you got all these right as you're going through your lesson on Friday. So remember how to find the degree of a monomial. To find the degree, you add up all of the exponents. That's attached to the variables, right? So we have a 3 plus 4 plus 1. 3 plus 4 plus 1 is 8. So this answer is 8. All right, the next one. So here we have where we're combining like terms. So this is like this term. So we're going to add 7 plus 4 and get 11. So 11 x squared y squared. And then we're combining these like terms. So -3 combined with -8 is -11xy. So that's going to be, where are we? This one, letter D, letter D. All right, moving on. Oh, it didn't work it. So what about this one? So here we have two numbers that have the same base being multiplied. So we add their exponents. So we get x to the 7th power. And then we have a power raised to a power. So remember, when you have a power raised to a power, you multiply. So 5 times 2 is 10. So this one is letter C. And then the last one, make sure you distribute that 3 to everything. So even though we don't see that, that's 5 to the first. So we're going to multiply 1 times 3. So we have 5 to the third times x to the 15th. And then 5 to the third is 5 times 5 times 5 is 125. So the answer is D. So what a good review. I like that. All right, so then today we're going to, for Friday, we're going to remember how to divide binomials.
Please, there's no tennis practice this afternoon.
They're making announcements.
And also, there's no all-state practice.
No all-state practice. No track practice. Okay, so now when we're dividing monomials, so anytime you divide numbers, so basically I would have 8 A's across the top, right? 1, 2, 3, 4, 5, 6, 7, 8 divided by 5 A's. 1, 2, 3, 4, 5. So just like 5 divided by 5 is 1, so is A divided by A. These A's cancel. These A's cancel. These do. These do. And what am I left with?
Wrestlers and baseball players, please go to the bus area. Teachers, please complete your daily rounding and send the first load of car riders to the front.
It's the end of the day. So what am I left with? I'm left with A to the third, 3 A's. So basically what we're doing is we're subtracting those exponents.
Also, this is a reminder to all 8th graders, please remember to continue to work on your electives forms. And all students and teachers, please remember, in support of our Falcon family, to wear red or pink tomorrow.
Wear red or pink tomorrow. All right, so what about this? We're gonna divide those exponents, or we're gonna simplify them. We can divide 4 and 8 by 4. So 4 divided by 4 is 1, 8 divided by 4 is 2. And then we're gonna subtract those exponents. So we're gonna leave 1 on the top, which we don't need because there's gonna be other things being multiplied up here, and we don't need the 1. But we have to have our 2 on the bottom. And then we're going to subtract those exponents. So 5 minus 3 is 2. There's more x's on top, so that's where it goes in the answer. And then here, 4 minus 1 is 3, and there's more y's on the top than the bottom, so my y's stay on the top. So the only thing in my denominator is a 2. So that's the answer. All right, same thing. I'm going to divide 12 and 8 both by 4. 12 divided by 4 is 3, and 8 divided by 4 is 2. And then I have 5 A's on top and 1 on the bottom. So 5 minus 1 is 4. Since there's more A's on the top, I'm going to leave my A on the top. And then B, there's 3 B's up here, 2 on the bottom. 3 minus 2 is 1. And where will that B end up? It ends up on the top. B to the first power is just B. All right, I'm going to divide 9 and 3, both by 3. 9 divided by 3 is 3. This one is a 1. All right, what's x to the 5th divided by x to the 5th? 1, because if you subtract your exponents, you get 5 minus 5, which is 0, and x to the 0 power, like anything else, is equal to 1, right? So those are canceled. I have 1 and 1, and then I have 4 minus 2, which is 2 y's are left, and is it on the top or bottom? There's more y's on the top, so I get 3y squared. That's my final answer because the only thing in my denominator is a 1. All right, hope that makes sense. All right, now sometimes you'll have, and you've done these before, but just a reminder, sometimes you end up with more variables or numbers on the bottom. 1, 2, 3, 4, 5, 6, 7, 8. So we would still cancel by pairs. But when we subtract, 3 minus 8 is -5. All that means is that we still subtract, but we had more a's in the bottom, which is going to give us a negative exponent, which simply means we leave those a's on the bottom. Don't you agree? I have 1, 2, 3, 4, 5 a's on the bottom. I didn't have anything left on the top, but in a fraction, you can't leave the top blank. You have to put a 1 there. So that's the answer. All right, what about if I have 4 7s and on the bottom I have 5 7s? All my 7s cancel except for that one, right? So what's left on the top? Nothing, so I leave a 1 there. And on the bottom I have 1/7. Or if I think about the rules, I'm just going to think, what's 4 minus 5? Well, 4 minus 5 is -1. That's why these two numbers equal each other. They are equivalent. It's not considered simplified if you leave a negative exponent in your answer, though. That's why it's important to make sure you end up with a fraction. And when you take what's in the numerator and move it down to the denominator, that negative sign goes away. So once again, this is equivalent to make that a +1, that's in the numerator. I'm going to flip it down to the denominator. And once I do that, that negative sign goes away. And of course, 7 to the 1st power is just 7. All right, so what would be 7 to the -2nd? Well, to get that negative to go away, right now, the way this is written, my numerator is 7. I'm going to take the whole thing, flip it down to the denominator. That exponent, that negative disappears. So I end up with 1/7 squared, and 1/7 squared is 1/49. So that's just a reminder on your negative exponent rules. All right, so what about this one? Well, we're going to divide 20 by 10. 20 divided by 10 is 2. 2 is a 2. It's not 1/2, right? It stays in the numerator. But I have more x's in the denominator. So when I subtract 3 and 4 and get 1, I know there's more x's in the bottom. So my x stays in the bottom. 3 minus 4 is -1. That's why I would take that negative, move it to the bottom. Or just think of it this way. Just think of where were the biggest number of exponents? Where was the biggest number of variables or whatever you're working with? Now, negative exponents don't always happen in the numerator. Sometimes they happen in the denominator. And once again, in order to make that negative sign go away, we move it. So if it's at the bottom, we're going to move it up. So when we take this whole thing and move it up, the negative sign disappears. So if my 5 stays in the numerator, I move my x to the 4th up. My denominator would just be a 1, so I don't need it. All right, so we're going to simplify these. So x to the -3rd, I would flip it down to the denominator, and I get 1/x to the 3rd. All right, I'm going to divide 24 and 36 by 12. 24 divided by 12 is 2. 36 divided by 12 is 3. And then, so those stay where they are. And then the difference in 5 and 7 is 2. Since I have more x's in the denominator, that's where my x squared goes. All right, 4 minus 1 is 3. There's more a's in the top, so I'm going to put a to the third in the numerator. The difference in 3 and 4 is 1. Since there were more b's in the bottom, that's where my b to the first power goes. And that's my final answer on that one. All right, remember what you do when you have any exponents raised to a power. You're going to multiply every single exponent. In this case, they're all ones by the number 2. So we're going to have 4 squared x squared over 3 squared y squared. Now you can always simplify those coefficients that have an exponent. So 4 squared is 16 x squared. 3 squared is 9y squared. And that's my final answer. And then this one, we have that negative exponent in the denominator. We have to bring it up to the numerator. And my final answer is 8c to the third. This question says if the area of a rectangle is 24x to the fourth y square units, and the length is 4xy squared units, what would be the width of the rectangle, given that width is found by dividing the area by length? Well, we know our area, and we know our length. So it tells us in order to get the length or the width, we're going to divide. So we're dividing our area by our length. Well, 24 divided by 4 is 6, right? 4 minus 1 is x to the third. And then there's the difference in 1 and 2 is 1, but where does that 1 go? There's more y's in the denominator, so my final answer is that y goes in the denominator. So we know that the width is 6x to the third divided by y units. Okay, so that's how you do that one. And then I'm going to erase that, make sure you have what you need. I don't know where my buttons are. Oops, I didn't mean to do that. Previous. All right, I can't erase that. My screen doesn't look right. But anyway, let's do the bottom one. It's the very last one. That's a 28. So we're going to divide 28. Well, let's think of it. 28 divided by -4 is -7. That stays in the numerator. So -7. A to the fourth divided by a to the fourth is 1, right? Because 4 divided by 4 minus 4 is 0, and a to the 0 power is 1. And then the difference in 2 and 5 is 3, but there's more b's in the denominator, so my b to the third stays in the denominator. And that's the answer. So hopefully this will help you get through this week's work. Hopefully you remember most of that. If not, maybe now you do. And I hope everyone has a good week. Let me know if you need me. And I will talk